lab number 4, talking about function operations. So addition, subtraction, multiplication, division, and then composition. So just a reminder about the operations with functions. When we're dealing with functions in this form, when we're adding functions together, so the notation is f plus g of x. That means take the f of x function plus the g of x function. So if we're dealing with ordered pairs from those functions, it'll be the y values that you're adding together from the f of x function and the g of x function. Subtraction is the same rule. We have function f minus g of x. You're taking the f of x function and subtracting the g of x function. If you're dealing with ordered pairs, again, you're taking the y values and subtracting them. And then multiplication, function f times g of x. You take the f of x function times the g of x function. If we're dealing with ordered pairs, we're multiplying the y values. That's what we're doing. Division is the same rule. F divided by g of x is f of x divided by g of x. If it's ordered pairs, we're dividing y values. The composition, a little bit more difficult. We're taking f composed with g of x. So this is a little circle. It's not the letter O. F composed of g of x means take the g of x function and plug it in as x in the f of x function is what that requires. So you're taking the y value for g of x and making it the x value for f of x. So let's work out a little problem here with each of these operations using a couple of functions here. So we've got 6 divided by x squared minus 4. And then that's the f of x function. The g of x function is 5 plus x if x is less than 3, and x minus 3, x is greater than 3. So we have a piecewise defined function for g of x. So each of these operations is using -1 as the x value. So it would be good for us to find out, well, what is the value of each function at -1? The f of x is the easiest one to find because there's only one to plug into. So you plug in -1 squared minus 4. 6 over -1 squared is 1. 1 minus 4 is -3. So 6 divided by -3 is -2. G of -1, we need to find out which one of these inequalities does -1 fit in. Is -1 less than 3? Absolutely. So we are going to use the top piece to find that value. So 5 plus -1, which would be 4. So we're using the y values, -2 for the f of -1 and +4 for the g of -1. So to find f plus g of -1, that means we're going to take f of -1 plus g of -1. Since we already know those values are -2 plus 4, we just work that out, and the final answer would be 2. All right. B part, subtraction, same idea. We're taking f of -1 minus g of -1. Now we already know those values to be -2 minus 4, which would be -6 for a final answer. Multiplication, exact same idea. F of -1 times g of -1, which we know to be -2 times 4, which is -8. That's the final answer. And then f divided by g of -1. Again, we're taking -2 divided by 4. Reduce that, and we -1/2 as a value. And the composition, again, it's a little bit more difficult because we're taking the g of x value. So g of -1 is 4. We're putting in that into f of x. So f of 4 is what we're finding. So 6 over 4 squared minus 4. So that'd be 6 over 16 minus 4 be 6 over 12, which is +1/2. That's the final answer for that one. So again, composition, you take the x value, plug it into the second function listed, get that answer, plug that answer into the first function listed, and that gets you function composition. All right, the next part of this lab is finding the domain of these operations on these. So the first step would be finding the domain of each of the individual functions, because that's going to help us be able to state the domain of the operations. So if we find the domain of f of x, rules for domain are you can't have a 0 in the denominator. Division by x's is where that comes from. So to find the domain of f of x, we're going to take x squared minus 4 and set it equal to 0 to find out where the denominator equals 0. So x squared is equal to 4. Take the square root. X can't be plus or minus 2 because the square root of 4 is plus or minus 2. So the domain for f of x are all x's as long as x does not equal -2 or +2. And for g of x, when we look at the inequalities, and they kind of tell us what the domain is. It says all the x's as long as x is less than -3 or +3. And then this one says all x's as long as x is greater than 3. The only number that's left out there is the domain for this one would be that x cannot be 3. Okay, so that's the number that's left out of those inequalities. So we get that kind of for free in the piecewise defined. Now, the way domain works for addition operation is it's just the union of those two domains. So the domain for f of x can't be positive or -2. Also can't be 3 for g of x. So we just mash that together, and the domain would be all x's as long as x does not equal -2, +2, or 3. That's the domain of the addition. The subtraction would be the same rule. There's no difference in the addition and subtraction when it comes to domain of that. Multiplication would also be the same rule as with addition. Division introduces a little bit more to that because we're going to be dividing by these pieces under certain conditions. So if we're going to divide, with the 5 plus x, we can't have a 0 in that. So you got to picture what you're doing with that division. You're dividing 6 over x squared minus 4 divided by 5 plus x. Well, this becomes the denominator in that big fraction. So we got to know when does that equal 0. It'd be when x can't, x was -5. So one of our values for that would be x cannot equal -5. We already knew that x couldn't be -2 because of the domain of the original function there, and +2, and then 3. Turns out 3 is also if you did the 6 over x squared minus 4 divided by x minus 3. This part, when you set that equal to 0 and solve it, you also get 3. So we got one kind of already that we had for that. So domain, all the x's except for these 4 here. The composition is a little bit more difficult because you got to think, okay, I'm taking this one and plugging into that one. So we got to think, okay, well, f of x had its domain, x could not be equal to -2 or +2. So when we're doing composition, we're taking the g of x function and putting it in the place of x. So we need to know when does the g of x function equal -2, or when does g of x equal +2? That's what we've got to find. So we take those pieces, 5 plus x, and set it equal to -2. We take 5 plus x, set it equal to +2, and solve those. So if we solve that, that's going to be -7. We solve this one. That's going to be -3. So those are going to be values that x cannot be. And then I've got the other piece, the x minus 3, that I've got to work as well. So I've got to take all those pieces from that piecewise and find out when do they meet the things that are thrown out from the domain in f of x. So 3, or x minus 3, excuse me. When does that equal -2? Well, that's going to be +3. That's going to be +1. But that positive 1, that's never going to happen for x minus 3 because the piecewise defined function says, oh, well, x's are already greater than 3 there. So that one's, that we disregard that one because it's already taken care of by the inequality. And we take x minus 3. When is it equal to positive 2? If I plug, add that, plus 3, that's going to be 5. And 5 is greater than 3. So that is going to be a value that we've got to take into account. So our domain for the composition is going to be all x's as long as x does not equal, and then we've got the ones that we've listed here. So -7, -3, 3, and 5. That's the domain of the composition. Composition is a little bit more difficult, but that's lab number 4 for Math 110.